Hello and welcome to part 3 of my Commodore 64 side-scrolling basic game video set. Today's video I'm going to show you how I made the sprites. I'm going to show how I got them into the program. And I'm going to show you where I'm at in the program. And then talk about a few other topics that could help you in your programming. First thing here is showing the sprites, how I made the sprite, the Code Devil. I'm using this software here, which I believe is called Commodore Cheetah Sprite Maker. It was created by Alan Monks. Looks like this version here is from July 2012, so it's a pretty recent version, which is good. Basically, you just click and point with your mouse. You can draw. And some useful stuff with this is it lets you create many different animation frames. It gives you, in this section here, you can see that's the sprite normal size. This is the sprite if it's stretched vertically. That's the sprite, of course, stretched horizontally. And that's the sprite stretched both ways. If you go to sprite tools on here, you can see all your sprites at once here. I got basically the standing. I got 4 animations for walking. I kind of use this off of, it's like based off of Mega Man. Mega Man's the same way. You got one where his legs are close together and his arms are close together. And you got another one where his right arm is out in front of him, left arm is behind him. Same as the other one. And you got this one where the left arm is out and the right arm is behind him. So as you scroll through these 4, he'll be, of course, running. And you saw that in the previous video of mine. So how do you get the sprites from here to your Commodore 64? Several different ways. Using the export function. You can export it as a text file. And if you do that, you get a deal like here, where it shows all the numerical data for all your sprites. It goes all the way down to show each sprite that you have. Each frame you have drawn. It also includes the number for the color, multicolor 0, multicolor 1, and what size you want to use. And it's just these numbers. You can print this up, I suppose, or if you want to do a side by side, you just poke these in. 13, 1, 16, 0, all the way down. 63 digits to one sprite. Now this is kind of a nightmare way to do it. It's easier than doing the whole thing by hand, but this doesn't save much time because, trust me, I know what it's like to have to do like a data statement with 63 numbers for just one sprite frame. It's not fun. It's really easy to screw it up, and then you don't even know where you're screwed up. It takes a long time to find out which number you entered wrong or where you entered it wrong. And so, a different way you could also export it is as a Commodore sequential file. This will save all the numerical data into a sequential file. If you're not too sure what that is, you can look that up in the reference guide or even just online. It's a file type that just holds numerical data or string data in a sequential fashion. Kind of like in a basic program where you have a read and data statements. You read from the sequential file, and when you do that, instead of having to have a bunch of data statements in the basic program, you don't have to have that. You only have to have the sequential file on disk, and it reads it straight from disk. And of course you can read the value, then poke it, read the next value, poke that, and so on and so on. And that's how I did it on here, which with the counting loader. I'll show you that soon. Another way, save it as an action replay sprite image. or a sook sprite. And that's if you're using those programs. So, here's my counting loader, which is written based off of, it ties right into the sequential file made by this, and it loads the sprite into memory. I've shown you this before in a previous video. Basically what it does, first line is it puts the sprite there, moves it over. I have a loading screen counting up as it's loading, and it's showing animation by animation frame as it loads it in. Once it reaches 100%, that means the sprite's fully loaded. And then I have a little animation here where it just jumps back and forth. Okay, so let me turn them off. Right. This program looks kind of monstrous, but most of it is some test coding in there, and mostly just the animation aspects of it. The main things to pay attention to is how it interacts with the sequential file. First you gotta open. And I got the name of the sequential files left and right. Get number 5, which is 5 is open. Get number 5. Each time you do a get number 5, pardon me. Fuck. Every time you do a get number 5, you get the next numerical value. It actually comes as a chur string. So all you gotta do is poke the ASCII value of the chur string. Now do T string, get number 5 comma T string. That makes the next value from the sequential file become T string. And the reason I do T string plus chur string 0 is just in case get number 5 returns a null value, which it can. It shouldn't, but it can. And if it does, if you try to do an ASCII of a null string, you get an error message, and the program will error out. So if you add chur string 0, then it's just going to, the null becomes a 0. Now it's important when you use sequential files, once you're done with it, you want to close it. Especially important if you that you close your sequential file before you save your basic program, because if you have a sequential file open when you try to save your basic program, they'll become cross-linked, and basically that can lead to the files becoming corrupted on the disk, and you could lose one or both files, either the sequential file or your basic program. So always make sure when you're done, you close it before you save your program or really do much else. Once you're done reading your sequential file, close. Alright, let me move on here to show you a little bit of where I'm at. I got some blocks loaded in the program. For now I've turned off the scrolling so it's easier for me to program. And I got some blocks here that just randomly go to different places. Set my speed up right here. Put my refresh rate right. Here we go. There you go. Right now I'm getting at about 20 frames per second, which ain't bad for basic. I got 8 sprites on here. Of course, 7 of them are just white blocks, and then he's the 8th. He's actually sprite 0. As you can see here, I got it set up to where it can go all the way over to the right. I got that most significant bit reading. But as it stands, there's nothing I could do with it. There's no really interaction here. They're there, but nothing happens. Now, I added coding to make these blocks where you can jump on top of them. Go ahead and load that up. But this is where I'm coming into a problem with making my side-scrolling game 100% in BASIC, because the coding required to make him interact with the blocks is really slowing it down. See how it's kind of like in slow motion now compared to before? But now he could jump on the blocks. He could jump through blocks, but you can stand on them. Climb all the way up to the top here. And fall all the way to the bottom. See how it's slowed down? I think now I'm running at about 10 frames per second, which is kind of pushing it to the I think to the max. There's not a lot more I could do in BASIC. There's only a little bit more I could do before this game's pretty much as it can be. I can't take it too far below 10 frames per second before it just becomes completely unplayable. I could go back into the program, update all my coding, like my XS and my YS, those variables I talked about in my last video in the description, and I can speed those up so it'll kind of offset. He'll keep going the same speed as he did before, but it'll be kind of more jumpy, you know, the lower frame rate. I can do that to get his speed back up so he's not slow motion compared to before. What's next here? Alright, so next I'll go through the list, the program. First part here is just the beginning initializations. First thing I do is I poke 56,48 in CLR. What this does is it shrinks down the amount of memory BASIC can take. I'll get an out of memory error early. It'll tell me that I'm out of memory because I reduced the amount of memory BASIC could have. The reason I did that is so I could have more space for my sprites and my character graphics information. Next thing here, x equals 80. That sets the horizontal spot from the beginning at spot 80. dr. Pull up my variables list here. dr is which sprite to show, which frame to show in the sprite. Starting off, it shows the standard one where he's standing, looking to the right, and that would be this one. I'll show you. Just a standard looking to the right. XS equals 5. XS is the speed. Oh man. XS is the, as I mentioned in the description of my last video, it's this horizontal speed of the character, how fast he's going. A positive value of 5 will send him moving to the right, 5 pixels per step. SL, that's just a temporary variable I'm using, which is going to work down here for the initialized sprites section. Y equals 80, so I'll put some X80, Y80. DF equals 0. DF is direction facing. That could have a value of, I believe, 0 or 1. 0 is facing right, 1 is facing left. This print is going to, I believe it changes the color of the characters. FL equals 200. That's your floor variable. This is floor. You set a Y value here, so by default it's 200, which is around down here. So this section here, he'll never, if the guy falls, he'll never go below 200. Or technically, I guess, the Y value will never go above 200, so it'll stop at 200 as the floor. SM. SM is the screen scrolling. This will be a value supposed to be between 7 and 0, but I set it to 8. That's how I save code for later for getting it started. The next line we got is a for next loop for BL equals 1 to 7. BL is basically block. It's a part of the block. This is the block loading. And what it's doing for each one, I'm using arrays for X and Y. 1 through 7 for sprites 1 through 7. Now remember, sprite 0 is your main character, so it's always going to be, the array is going to be 1 through 7. So first it's X1, sprite 1, block 1. It's going to be a random location. X will be random. Same thing, Y will be random. So it'll put blocks all in random places as it goes from 1 through 7. 53272. This poke turns off the characters and turns on character graphic mode. Print char string 147, which is a clear screen, and then a whole bunch of down arrows. Print a bunch of spades. Jump back up to the top, print some more spades. That makes the ceiling and the floor. And turn the graphics white. Actually, this one up here, I believe it makes it pink, so that they're pink. And then turn the cursor white after that's done. Then we go into the initialize sprites. We're using our SL 53248. And this just turns on things like, turns the sprites on, sets their colors, sets them if they're going to be, expanded or not expanded. And then at the end, since it's 2040, sets up the pointer. So that's the first part of the program. The initialization draws the screen, sets up the locations for all the random blocks that will be on the screen, and then turns all the sprites on and gets them set up. And now for the next part. Next part is the physics. Here's our physics calculation. Just a little bit of a monstrous code here, but it actually does a lot of good stuff. First line here, x equals x plus x speed, xs. What'll happen here is if xs is a positive value, say it's 5, okay? X plus x equals 5. So in this instance, it moves the spread over, say 5 pixels. Now if x is bigger than 314, which means that your sprite's about to go off the edge, or if x is smaller than 31, which means it's about to go off this edge, then x equals x minus xs. So it's a plus 5, but if it's bigger than 314, then it's minus 5. It puts it back, so you can't go off the screen. It bounces you back. Now the cool thing about the way this code works is if xs is a negative value, say it's negative 5. So that means x equals x plus negative 5, which is actually x equals x minus 5. So it would move left 5. And that would come into if x is smaller than 31. If you go 5 over and you're off the screen, then x equals x minus negative 5, which is actually plus 5, moves them back. That keeps them on the screen that way, horizontally. Next line here, if fr FR is checking if the fire button is pushed down or not. If the fire button is pushed down, FR will equal 0. If it's not pushed down, it'll equal 16. So, if the fire button is not pushed down, and your Y speed is less than 0, that means that if your Y speed is less than 0, that means your character is in the middle of jumping up. He's going up the screen. So if the fire button is not held down and he's jumping up, then reduce the Y speed by 1.2. What this line does is it checks for, it's a part of the variable jump. If you hold the button down, you can jump higher, but if you're jumping and you let go of the button earlier, then he'll fall sooner. And that's how that works. It reads that. If it's in the middle of jumping, it slows it down and brings you back down sooner. Line 180, y equals y plus ys. Same thing as this one up here, x equals x plus xs, except that this is handling vertically. Ys can be positive or negative. If it's positive, then y is going to go down. If it's negative, y is going to go up. Your sprite. If y is bigger than 255, which of course it's never going to be, because remember our floor FL is set to 200, but just as a safety check, if y is bigger than 255 or y is smaller than 0, then retract that movement. If say y is negative 10, if you're jumping up negative 10, and it's smaller than 0, then it's going to take that 10 back away, so it stays within the boundaries. Because if y is actually ends up bigger than 255 or smaller than 0, when we do our poke, it's going to give an error and the program will stop. So it always has to be between 0 and 255. Next one, line 190. This is the friction line. If XS, the speed, horizontal speed, is less than 0, which means that he's currently moving left, then XS equals XS plus 1. So if he's moving left 4, say XS is set to 4, so he's moving left 4 pixels. This code is going to slow 4 down to 3. Now, this is a safety code. If XX is bigger than 0, then it equals 0. So if you add 1 and somehow it became bigger than 0 after that, set it to 0, so that when you're running left and you slow down at a stop, you don't start going right. It's just a safety code. Next line. Ys equals ys plus 1. That's our gravity. If y is bigger than floor, then y equals floor. So, if somehow y plus ys is bringing you below that 200 mark, then it's going to make y equal 200. And then y speed equals 0, so you're not falling anymore. Next line, line 201, if ys, which is vertical speed, is bigger than 9, then vertical speed equals 9. This is a cap for how fast he'll fall. You'll never fall more than 9 pixels per step, because it'll cap at 9. That way you don't fall super fast, because if you fall too fast, you can fall right through the floor. And I'll show that later with the blocks. And then line 210 is pretty much similar to line 190, except it's the reverse. If your horizontal speed is bigger than 0, if you're moving right, then subtract the speed by 1, the friction. And of course that same safety code if it's to keep it from going the wrong way. Next line, 220. JS, that's for the joystick. 56321, that's the joystick poke address. So it gets the poke address of 56321. Fire button, like I told you before, that's going to be either 16 or 0 if the fire button's being held down or not. And that basically ties into that jump code. That's where this is at for here. That's all that's really doing, is reading the FR for up here to know if you let it go, so that if the jump will be short or a full jump. Next line, 230. If XS is smaller than 1, then X equals X minus 0. If it's smaller than 0, then it equals 0. What this is doing, I got this turned off. That's the part of the scrolling. Like when I have this forced scroll back on, I'll change that 0, 0, 0 to say 1, so it'll be moving left along with the screen. These next two lines are related to the high bit of the X address. The screen across is 320. It's 320 by 200. But when you poke or peek, you can only poke a number between 0 and 255. So, but X can equal more than 255. And this reads that and catches it. So if X is smaller than 256, then HX, which is the high X, equals 0. If X is bigger than 255, then HX equals 256. And that makes it real easy for me to poke where he's supposed to be. Say X equals 302. Then what will happen is HX will be 256, right? So if HX is not 0, which means X must be higher than 255, if HX is not 0, then you need to poke in both these lines, 260 and 270. Both of these lines handle the poke for the high bit. To put him above, to put the character up beyond the 255 barrier. So if it's anytime X is higher than 255, that's going to be on, so it'll be on the right side. Anytime it's less, it'll be off, and it'll be on the left side. So then after we did all our physics calculations, we poke our Y, then we poke our X. Now, X, we actually poke X minus HX. Now see what happened here, HX equals 0 if it's less than 256. So if X is, say, 200, it's going to poke 200 minus 0. Right? Now if it's 300, what will happen is it'll poke 300 minus 256, plus that extra bit is on, so it'll be at the right spot at the time. Line 290, SM, remember SM is our screen scrolling. Right now I got it turned off, but basically it's, it's poking the screen scrolling if I have it on. So that's that's the physics calculations part. Now we'll move on to the next part, which is our joystick reading. It's pretty small, pretty simple. Get the value of the joystick, get the value of the fire button, update the value of the joystick. You got different values, if you go right or left, you get 8, 4, 1, 2, 3, 4, 5, 6, 7, 8 if you go in different directions, right? So if the joystick is reading as 8, that means the joystick is being pushed to the right. If the joystick is being pushed to the right, then increase the X speed by 2. Now, if the X speed is bigger than 5, then cap it at 5. That means you can never go faster than 5. So go 2, 4, 5 and stay at 5. And if JS equals 4, that means you're pushing left. Same thing, subtract 2, it's less than -5, cap it at -5. So that you're going left. 2, 4, 5, and it stays at 5. The next line here, line 370. Oh boy. That one is reading the fire button. Right now I got the fire button set up for jump. I might end up having to change that if I want to make the fire button into if I want to have Code Devil have a certain type of a weapon, I'm going to have to change that. But right now I got the fire button for jump. So if the fire button equals 0, which means it's being pushed, and if Y is bigger than the floor minus 1, which is basically a safety way to say that is he on the floor? Is he standing it down? If he is, then set your Y speed to -10. That'll send him going up. That'll send him going up. And of course, if you remember back in our physics part, every step Y speed is brought back towards 0, so it'll be -10. I believe it was 1, I can't remember for sure. So it'd be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, then he'll start going down. And that's the joystick reading. Reads left, right, and jump. The next part we got is mostly the animating part, drawing everything. This part's pretty simple too compared to the physics part. So what we got here, if our X speed is bigger than 0, which means he's moving to the right, then the direction facing is 1, which means face right. Same thing, if it's less than 0, that means he's going left, so direction facing 0, which is left. Now I got an override for that, which is here, line 430 and 440. If Y is smaller than the floor, which means you're not standing on the floor, you're above the floor, and the direction facing is left, then you want to poke 203 in line 2040. That tells you what sprite to draw. Sprite 203 is going to be this one. It'll be jumping left, right? Jumping left, okay. So it'll be jumping left. It'll be the jumping left one. There's a jumping left animation. The same thing for same thing the other way around. If you're facing right, then you'll be jumping right. And that'll be this one, jumping to the right. Now, if he's not jumping, then we go on. Because otherwise, if he is jumping, then we just get out of all that and go next to the next part at go to 540. We'll skip all that. But if he's not jumping, then he must be wanting to run. SP on line 450 there. SP. That is our speed pointer. That is going to make our running animation. And it goes by +30, or 0.30, sorry. This actually just makes the animation go slower, so instead of every step going 1 animation frame, it freezes for a couple times. And if there's only 4 frames, see, there's only 4 running frames. There's 1, 2, 3, 4. The other way, 1, oh, sorry, other way, it's 1, 2, 3, 4. So, it'll cycle these 4 frames for him to run. Or if he's running left, it'll be these 4, 2, 3, 4. If it's bigger than 3.99, which means we're getting past the 4th one, we'll put it back to 0, 0 to 3. Our next line is if we're standing still. If X speed is 0, which means we're not running in either direction, we're standing still, and direction facing equals 1, which means that we just, last read was facing right, so if we're standing still and direction facing is right, is recorded as right, then we need to draw sprite 192. Sprite 192 is that one, standing and looking to the right. Set SP to 0. There's no animating for standing still. It's just 1. SC. I should have took that out of there. SC. SC. I was going to use SC for the animation speed. I was going to have it be when he's running faster, it'll animate faster, and when he's running slower, when he's moving slower, it'll animate slower. I tried that, but it wasn't working too well. It was taking a lot of code, it was buggy, it was slowing down. So I took it all out and realized it wasn't any better one way or another.